It's time for 7.3, day one. We're going to be solving some basic trig functions. Now you might be wondering, Mr. Allen, why are you dangling the mask here? I'm one-strapping it right now because I'm in a space where someone might end up walking in which case I need to make sure that I'm ready to rock and roll, okay? So that it could happen, I don't know, at any moment in time. All righty, let's go for it, shall we? So, exact answers only, okay? Let's do this. So this plays into our inverses to a point. So for our first one here, we have 2 sine of theta minus 1 is equal to 0, okay? So, and we're going to talk about these steps up here in just a moment as we're solving. So I would have, let's see here, I'm going to try to get theta by itself. So that would equal 1. Divide by 2. And I would get sine of theta is equal to 1/2. So we're trying to think, well, for what angle would I get 1/2 for the sine, right? Well, let's see here. Well, how about we draw some triangles? I love triangles. So for positive 1/2, sine is opposite over hypotenuse, if you need that refresher. So my opposite would be 1. My hypotenuse is 2. This is a root 3 then. All right, and where else could I possibly get that? That would also be where is sine positive. Perhaps you need a little refresher. A, S, T, C. Second quadrant, and the triangle we draw would also confirm that 1, root 3, and 2. That's a negative root 3 in that case because it's going to the left. All right. So what angles are those? It says between 0 and 360 here for 1 through 4. So this would be, the first one would be a 30-degree angle. And the next one, because it's a 30-degree reference, for this one over here, I could do 180 minus 30 because I want to go back 30 from the x-axis there, the positive x-axis. So I'd have 150 degrees as well. And those would be my 2 solutions. Now you might be like, hold up, I thought inverse sine was only defined in the first and fourth quadrants. This has nothing to do, this doesn't have inverse sine right here. Yeah, we're still figuring out what angle would be, but we never said the inverse function was defined or anything like, we didn't restrict or anything like that. So we're gonna have multiple solutions for these types of problems. Let's continue with problem number 2. I'm gonna go ahead and switch it up. Ooh, I'll go red. I'm gonna go red. All right, same kind of idea. I would subtract 3, so I'd have cosine of theta is equal to -1. Okay, so where does that happen? Well, let's think about our quadrantals. So for cosine being -1, cosine is my x-coordinate. That's all the way over here. So my answer would be 180. I was almost going to write pi, but I guess it would have worked there. All right, 180 degrees. All right, so now that we've done a couple of them, let's just make sense of these steps here. First one, solve for the trig function. We want to isolate sine, cosine, tangent, whatever it might be. Okay, we're going to identify the quadrants, if any, right? So for the second one is a quadrantal, so not in a quadrant. For the first one, we knew it was going to be positive in quadrants 1 and 2. And we drew our triangles there, right? We're going to evaluate the inverse. We're only use positive values because that's going to give us our reference angle. That'll come in later when we start using the calculator a bit. You'll see it there. And then we're going to find both solutions. Sometimes there's even more solutions, just kind of as we get to more advanced, okay? Let's continue. So for this one, how about I multiply by 2 to get rid of that 1/2? So if I do that, I'd have -2/4, which is -1/2, is equal to cosine theta. Well, cosine is going to be negative in my second and my third quadrant. So let's draw that up. I'll zoom in a little bit here because it's a little... All right, so I have -1, 2, and then this is root 3. Don't have to write that root 3, but hey, why not? There we go. Well, what kind of angle is this? Well, this angle of rotation here, that's a 60-degree reference with that root 3 there. So that would mean that this is 120 degrees. And then if I go 60 past the 180, I'd have 60 plus 180. That gives me 240. So 240 degrees for the other one. So those are my 2 solutions for problem number 3. I like it. Excellent. Fantastic. Wonderful. Keep on moving. All right, number 4 here. I'm going to go with an orange. All righty. So if I want to... All right, so once again, we're going to isolate the trig function first. So I'm going to add 3. That gives me -1 is equal to tangent of theta. Good thing I had this strapped. Somebody walked in here. I had to pause the video. Strap up. All right. So when is tangent theta equal to -1? Well, first off, tangent is negative in both my second and my fourth quadrants, according to my ASTC, right? Or if you just remember it. So I'm going to draw my triangles accordingly. Second, fourth. Now, tangent is opposite over adjacent, right? So my opposite side or my adjacent side needs to be negative. So this gives me -1 and +1. And then over here, I would have -1 for my opposite, +1 for my adjacent. All right, and this is a 45, 45, 90 triangle, in case you didn't recognize. So that would mean 45 is my reference angle. So I would do 180 minus 45. That gives me 135. That's in my second quadrant right there. And then let's see here. We got 360 minus 45. So I can go down, right, in that fourth quadrant there. So lovely. I'm going to get 315. Cool. There's my two solutions in the second and in the fourth quadrant. I love it. Fantastic. Wonderful. All right, so here's what I had previewed with you guys of wanting to use your positive reference angle, okay? And then we'll position it accordingly. So for this one, cosine of theta is equal to 2/5. This is not nice, okay? This is not some wonderful, 30, 60, 90, or 45, 45, 90, but we can still position it. So we know that cosine is positive in both the first quadrant, adjacent, hypotenuse, right? Cosine is adjacent over hypotenuse. I don't know what the other one is, but I really don't care. And then it's going to also be positive over here in the fourth quadrant. Cool. So that can help me find my answer. But I'm going to use my calculator here. I'm going to do the cosine inverse of 2/5. That'll give me this angle right here, which is also my reference angle. So let's pull up the calculator here. It's asking for it in degree mode, right? So it says solve for all between 0 and 360. So I'm going to have to change my mode, make sure it's in degree. Otherwise, I'll be getting radians. All righty, let's get back to it. And we're going to do cosine inverse of 2/5. Awesome sauce. So it's 66.42 degrees. Okay, so that's one of my answers in quadrant 1. 66.42 degrees. That is the nearest hundredth, 2 decimal places. We're good to go. Now, for my other one, I'm going to do 360 minus that reference to get my other angle there. I guess I could probably do that in my head, but I don't want to make a mistake in the video, So I'm going to type it in like, man, I feel like I should have been doing this in my head. All righty. 293.58 degrees. And I'm forgetting, I actually have my notes off to the side here with the answers. So, I guess I could have just done that. But there we go. There's our two answers. So it was first isolate the trig function, do the inverse of it in your calculator to get your reference angle, and then you can position that accordingly. Awesome. All righty. Cosecant. Yeesh. Cosecant. Well, first off, let's isolate the trig function, right? So I'm going to multiply by 4. And I'll get cosecant is equal to 12 over 2, which is 6. Maybe you can think about that as 6 over 1. And how about I do this? Cosecant is the reciprocal of sine. So I could also say, oh, don't forget that theta there. Sine of theta is equal to 1 over 6. Okay, now it's a little more reasonable. So if I plug this in if I throw this on the xy coordinate plane, I'd have 1 and 6, right? That's positive for sine. Where else is sine positive? Well, that would be in the second quadrant, 1 and 6. I don't care what the adjacent side is there. It's not really helpful for me in this particular problem. Let's pull up our calculator and plug it in. So I get sine inverse of 1/6. And I get 9.59. And then to get my second quadrant, I would do 180 minus that. And again, I do have the answers, but I'm plugging it in because it's fun. You know what I'm saying? 9.59. So I do 180 minus that, and I would get 170.41. So 9.59, 9.59, and 170.41. Perfect. Awesome. That's a niner. That's a niner right there. All right. Good. Easy. I feel like when we're dealing with degrees with those problems, it's easier, but we are going to also deal with radians, which we'll get there when we get there. All right, radian time, but exact answers. Okay, so we're not dealing with any messy stuff. So again, isolate the trig function. So I would have, and I'll switch up some colors here. We're gonna go pink. That's fun. I'll subtract 8. So 4 secant of theta is equal to negative 8. Divide by 4, and I get negative 2. Or the reciprocal of that would be cosine. So I'd have cosine of theta equals negative 1/2. All right, let's position it accordingly. Cosine is negative in both my second, so this would be negative 1 and 2, and in my fourth, this would be, not in my fourth, my goodness, that's where it's positive. My third, negative 1, and I'd have 2 over here. And then what's my opposite side here? Because cosine is adjacent over hypotenuse. What's my opposite going to be? This is a nice 30, 60, 90 triangle here. Or, we're going to be dealing with the radian aspect of it. So what is my reference angle for this one? Well, my angle right here, that would be in this case, a pi over 3 reference, right? So if you remember your unit circle, you can either use that or you can do pi minus that. I think most of us would probably be a little more comfortable with saying that this is 2 pi over 3. So 2 pi over 3 is one of the answers. And then the last one, and I'll do a slightly different color to show that rotation. Whoop. That one is going to be 4 pi over 3. So those would be my 2 solutions there for this one for each quadrant. Quadrant 2 and quadrant 3. All right, awesome. I prefer remembering my rotations with that rather than doing pi minus and 2 pi minus or pi plus, because then you're adding fractions. It's a little funky. All righty, let's keep going. Let's keep cruising. Green. All right, so I'm going to add. So I get 18 cosine of theta. This looks terrible right now, doesn't it? But I think it's going to work out okay. Divide by 18, and now I'm going to get, that reduces down to root 2 over 2. So cosine of theta is equal to root 2 over 2. So if I draw this up, I know that this is a, you would have your adjacent as root 2, but your hypotenuse is 2. But I know that this is a 45-degree reference or a pi over 4 reference right here. This is like a 1, 1, and a root 2 situation that's been rationalized, right? So I know that this is pi over 4. And then where else is cosine positive? Well, that would also be in my fourth quadrant here. So what's my almost default? That it would be 7 pi over 4 then, right? Or you could do 2 pi minus pi over 4. It's going to give you 7 pi over 4 for your other one. So I'll just jot those both here. Pi over 4 and 7 pi over 4. Beautiful. Love it. Awesome. Fantastic. And wonderful. All right. Here we go. Here it comes. Round answers to the nearest hundredth. All right. I think what this would be kind of helpful here. I'm going to jot this down off to the side. Let's remember there is a decimal form of pi. So what would those be? We'd have 0. I know that pi is 3.14, which would make this 6.28. And I want to say this is 1.57. And this last one is 4.71. All right. So let's remember those decimals as we're working through this, okay? Mainly the 0 and 3.14, okay? All right, let's do this. So I have tangent theta is equal to 3. There we go. And let's plug, so we're going to do tangent inverse of 3. Now, first off, that is opposite over adjacent, right? So I'd have something like this. I don't care what my hypotenuse is, but tangent's positive. Where else is tangent positive? In that quadrant right there. Okay. So my answers are going to come from my first quadrant and my third quadrant for this particular one. So let's pull up our calculator here. And we're going to do tangent inverse of 3. Ooh, almost forgot. Make sure you change your mode to radian. We are in radians for this particular problem just because it said so, right? Okay, so now if I hit enter, I have 1.249 or 1.25 radians, right? That is in my first quadrant, right? If I look at my decimal equivalent, so 1.57. So all of them are kind of important, not just the 0 and the 3.14, but I know I'm in my first quadrant. So that is my answer for the first one, 1.25 radians. Okay, 1.25 radians. Okay, now for my third quadrant, let's see here. We're going to go, instead of like 180 plus whatever that reference is, I'm going to do pi plus that reference, right? So pi, or I can just do plus pi. That would give me my third quadrant there. Had it been in the second quadrant, I would do pi minus that value, right? So it's 4.39 radians. Awesome sauce. Big fan of that one. Big fan. I like it. Good stuff. So it's all about getting that reference, okay? Sometimes when we plug these in, you're going to see on this next one here, I believe, that sometimes when you plug it in, it might be a negative, and that's not going to give you a reference. I find it best to find your reference and then use your little brain ski to position it accordingly. All right, let's do this next one here. Come on, marker selector. We'll go purple. All right. So if I subtract 2, I'm going to have 3. That was close. That was visitor 2. Had to pop the pause, strap up. There's a printer in here. All right, you may have heard it. So I would subtract 2. Let me write that again because it was a kind of a terrible 3 as well. I don't know why I have trouble with my 3s. Had another visitor. All right, so divide by 3. This is how much I love making videos, you guys. I'm gonna find a way to do it. And then why did I put -3? There we go. So I have sine of theta is equal to -2/3. Okay. So when I plug this in my calculator, let's think about, well, first off, where is sine negative? Sine is going to be negative in my third and my fourth quadrant there, right? Let me move that a little bit out of the way here. I'll put it down here. So in my third quadrant, I'm going to have opposite hypotenuse, boom. And in my fourth quadrant, opposite hypotenuse, okay? So I know where it's going to be. And if I were to plug that in as is in my calculator, here's what we'd have. So if I did sine inverse of -2/3, I'd end up getting, let's see here, hold up. Oop, am I too close? Sometimes it doesn't hit enter if I'm too close to my face. There we go. I'd get a negative angle of rotation. So you could think of that as, you know, how you'd like. You could make it positive, and now that's your reference angle. But that right there would be this angle of rotation. But our answer is supposed to be between 0 and 2 pi, right? So I have to change that in some way. And we could just go ahead and make it positive in our calculator, or what I personally like to do, anytime I'm dealing with a negative in the inverse, what I'm going to do is I'm going to do sine inverse of 2/3, make it positive, and then I know that this is my reference angle, okay? And now I can use what I know to position it accordingly. If it's in the third quadrant, I'm going to do pi plus that reference. I forgot. I can't arrow up on this thing. Hold up. Second, previous answer. Enter. There we go. So that's one of them. Okay. And then I would do 2 pi minus that point. And I have to type it in. You can arrow up on many of the new calculators, but this one's not nearly as awesome. I'll just go at least 4 of them there because that'll be fine. So I have 5.55 for my answer on that one. So that would give me my third quadrant, the 3.87 radians, and then the 5.55. So once again, when we're doing this style problem, I like to put the positive, whatever it is. If it's -2/3, I'm going to put +2/3. If it's +2/3, I'm going to put +2/3. If it's -1/4, I'm putting +1/4 in there so that I get that reference angle, right? My reference was 0.7297. So my reference angle point was 0.7297. And I used that to get the other spots because I knew where it was. I knew it was in the third quadrant and the fourth quadrant. Just sneezed. Bless you. Thank you. Thank you. All right. So find your reference, position it, by either adding or subtracting from pi or subtracting from 2 pi. Awesome, fantastic. I've said it a million times now. I think we can move on. All right, we're going to go on to a little bit more advanced, a little bit beyond basic, if you will, right? Moving on beyond the basics of trig solving. So we're going to use some other fancy algebraic techniques. Factoring is going to come into this thing. I knew you were like, hey, can we do factoring again? I love factoring. Let's do that. Oh, we are. Oh, we are. So GCF's going to be involved in there. There's going to be regular linear ones. There's going to be factoring, like AM method, even with like rainbow method, leading coefficient, squaring technique, all sorts of good stuff. All righty. So things to remember with your greatest common factor, it's got to equal 0. If you factor something out, it's equal to 0. Okay? With the linear method, that was like what we were just doing there. You're going to equal some kind of a number. Factoring method, you're going to set your factors equal to 0 and then solve. It's like having 2 mini problems. Just like when you learned factoring the first time, you're like, well, what do I do now? Well, now I solve 2 separate equations. And then squaring technique, will either be like, solving using square roots. It's going to be awesome. Okay. Let's do this. So I'm going to leave these tips up here for you guys. A couple of them will kind of come up, and I think I'm just going to touch on them as we go here. So for the first one here, all right, I've got 3 times secant squared theta or minus 4 is equal to 0. So I'm going to try and get secant squared by itself because then I can use square roots to solve. So I'd have 3 secant squared theta is equal to positive 4. Divide by 3. So now that I have that, I'm going to divide by 3. And I get 4 over 3 there. Now, I'm going to take the square root on both sides, which leaves me with secant of theta is equal to, don't forget about it, plus or minus 2 over root 3. Now, I'm not going to rationalize this right now, and here's why. Secant is the reciprocal of cosine, right? Well, how about I use that to my advantage? Cosine of theta is equal to plus or minus root 3 over 2. Cosine is going to be positive in quadrant 1 and quadrant 4, and then it's going to be negative in quadrants 2 and 3. So this is going to happen all over the place. Let's draw it up. So I'm not going to put all the numbers in there. It gets very, very cramped. But what is my reference angle here? This guy right here. That is going to be pi over 6. That's my first solution. Now, what's my pi over 6 reference, my 30-degree reference in the second quadrant? That is 5 pi over 6, and then it's going to be 7 pi over 6, and then lastly 11 pi over 6. There's my 4 solutions that exist in all 4 quadrants because it's both positive and negative due to taking the square root on both sides. If you don't remember your unit circle very well, I would definitely refresh that, especially when you're talking about your radians and how you're going to work your way around the unit circle. You could have also thought of it as pi minus pi over 6, pi plus pi over 6 to get the 5 pi and the 7 pi over 6 respectively. And then 2 pi minus pi gives you 11 pi over 6. But then you're dealing with common denominators and all this stuff. So I think just remembering your unit circle and how to count with them, best shape. Okay, awesome. Let's keep it moving and grooving, shall we? Oh boy, this one looks interesting. All right. Now, some of you will avoid the u substitution just because you don't like it, but I'm gonna go with u substitution. It's the proper mathematical way of going about this. So if I say that u is equal to sine of theta, okay, and I were to then change this into u squared minus 4u plus 3 is equal to 0. Now, some of you might be like, why u? It's a rather unused variable, so some old dude just chose it. That's the best explanation I can give you. Okay, sorry, that's it. So we're going to use u. So if I factor this, I'd have u minus 3 and u minus 1. That's going to multiply to 3 and add the negative 4. Okay, so then if I were to set these equal to 0, I would get u equals 3 and u equals 1. But don't forget, sine of theta is our u. Really having trouble with these 3's. And sine of theta is u once again, which equals 1. Can I have, let's see, think here. This is the same as 3 over 1. Opposite over hypotenuse. OPP, yeah, you know me, over hype, the hype man. Doesn't hypotenuse have to be the longer side? So this one's undefined. No solution over here, okay? No solution on that end. But I still got to solve the other one. When is sine going to equal 1? Well, sine is going to equal 1 at that first quadrantal up there, right? Because it's our y coordinate. So pi over 2 would be my solution for that one. Awesome. Fantastic. Wonderful. We made it through the first u substitution with factoring. Not bad. All right, let's continue here. So I'm going to divide by 16. I'll switch it up again. I'm going to go red. Divide by 16. So I get tangent squared theta equals 9 over 16. And I got to take the square root on both sides. Great. This is going to be terrible. No, it won't. Because guess what? Those are perfect squares. So I have tangent of theta is equal to plus or minus 3/4. And although the 3 and the 4 might look familiar and wonderful, this is not going to be a situation where we can do exact answers. And the directions did say up here, nearest hundredth when needed. Okay, so that's the situation we have here. This is not a 30, 60, 90. However, once again, because it's plus or minus, tangent is positive in 2 quadrants and negative in 2 quadrants. It's positive up in the first quadrant. That's a 5 for the hypotenuse. For those of you remembering your triples, well done. It's not important in this problem, but I'm still putting it there. And then it's positive down here in the third quadrant because this is -3 and -4, but that's still positive 5. Don't forget. All right, and then it's going to be negative over here and negative right here. So what I'm going to do is, first things first, I'm going to find my reference angle, right? So I'm going to use the positive. I'm going to take the tangent inverse of 3 over 4. That's going to give me this first quadrant angle, okay? So second, oops, I got to turn this bad boy on first. It was in power saver mode, right? It was on the computer. Tangent inverse, 3 over 4. And that gives me 0.6435. Now, if you remember, between 0 and 1.57 is the first quadrant, so that definitely falls in the first quadrant. So for quadrant 1, we have 0.6435. So I'm going to put that down here. And I know some people organize it like this, quadrant 1. And then 2, 3, and 4 for these. And we can jot them down accordingly. So I already forgot. First one here was 0.64, 2 decimal places. Cool. Quadrant 2. How am I going to get that? Well, I am in radians here, right? We are in radians. So to get this second quadrant here, and let me go with a light blue to show you what I'm talking about. My reference is that 0.64. So I want to go 0.64 back from pi. So I'll do pi minus that. All righty, so pi minus... Actually, you know what I'm going to do is this. Check this out. I'm going to hit, because it's old school. I'm going to store this as alpha A. So then I can just use that. Okay, there we go. So I'm going to do pi minus A, which is the 0.6435. And I get 2.49. Awesome sauce. I like it. Ooh, 2.498. So 2.50. All right, and then for my next one, for my next trick, I'll use purple here. I want to go down, right? I want to go past the pi. So I'm going to do pi plus the 0.64, or for me, I'm going to be doing the alpha A, using that store feature. We've used that before. Right? It's pretty awesome. It's pretty awesome. And I get 3.785, so 3.79. And then lastly, I'll go with, we'll go green here. I'm going to go back from 2 pi, right? So 2 pi minus alpha in my case. Or if you're able to just, arrow up, you can do that too. But I get 5.64 rounded, 5.64. And those would be my 4 solutions there in each quadrant. Nice. So a little bit scary dealing with the whole decimal aspect, but if you draw it up and you keep thinking about, okay, what does this mean? Get my reference angle, add it, subtract it based on where it is. So it's really a few parts there, right? Get your reference. Where is it located based on its positive or negative aspects, right? Or both of them. And then go to work, all right? Let's do number 14, 15, and then we are done as we are approaching a half hour here on this video. I appreciate you sticking around. I know how much you love a lengthy math video. One of my favorite things too. Just kidding. All right. 2 tangent squared minus tangent theta minus 1. We're going to be using u substitution again. U is equal to tangent of theta. So I'd have 2u squared minus u minus 1 is equal to 0. Now, I know some people will use like rainbow method. With a lot of these, it's going to be pretty easy to just do guess and check. That's the way I learned it anyways, back in the good old days. So it's got to multiply to -1. If I go with -1 here and +1 here, if I double check that, 2u and -1 gives me -2u. This would give me +1u. When I add those together, I do get -u. So this checks out. I guessed, I checked. America, freedom, rock and roll. Moving on. If you got a refresher on rainbow method or anything like that, feel free to ask in class, and we'll go over it. But for now, I get 2u plus 1 equals 0, and u minus 1 is equal to 0. So I'd have 2u equals -1, and u equals -1/2. So tangent of theta equals -1/2. And then I'm going to do the other one here as well. U equals +1. So tangent of u is equal to, tangent of theta is equal to +1. All righty. Cool. So on the left-hand side here, the -1/2, that's not a nice tangent value. So I am going to have to use my calculator on this one. Now I'm going to draw up where it's located. Tangent is negative in both the second and the fourth quadrant. Remember, that's opposite over adjacent. In this case, my adjacent would be negative over here. And in this case, my opposite would be negative, right? But really, I'm mainly just concerned as to where the heck it's located, right? So what I'm going to do, because if I plug this in as tangent inverse of -1/2, I'm going to get a negative angle of rotation, and then I'll have to interpret it accordingly. So I'm just going to go tangent inverse of +1/2. It'll give me my first quadrant answer, which is not the answer I want, but it'll give me my first quadrant, which is my reference, and then I can use that accordingly to position in the second and the fourth quadrant. So if I do second tangent and I do 0.5, 1/2, right? 0.5. Save one keystroke by doing 0.5. And I get 0.4636. That is my reference angle. I'm going to store that in my old school calculator here as A. You don't have to do that if you can arrow up and just grab it. So now what I would do is for that second quadrant, I'm going to do pi minus that value. Hit enter. Boom. There's my first answer in the second quadrant. And then I'm going to do 2 pi minus that value, that reference angle. And I get 5.819, so 5.82. And I have them written down off to the side so I don't forget. So in my second quadrant, this was, and I'll put that answer here. I'll do quadrant 2 and quadrant 4. Since we have so many solutions here, I think a little chart here might help. So this is 2.68, and then 5.82 is the other one. Awesome. So there's my 2 solutions in quadrant 2 and 4, which is where tangent is negative. I used that positive reference to help me get there. All righty. And then over here for 1, that is a nice one, right? That is a 45, 45, 90 triangle in quadrant 1. Okay, so that's pi over 4 for that one. And then where else is tangent positive? That's in the third quadrant, right? And that would be, let's see if I count it out, be 5 pi over 4. Boom. There are my 4 solutions, 2 of them in decimal because we couldn't do exact, 2 of them exact because we could do exact. Awesome. Again, I like the unit circle when trying to count them out like that, rather than doing like pi plus pi over 4. That way I don't have to deal with like denominators. All right, last one, I promise. So for this one here, it's not like an AM method type factoring, but it looks like I could either divide by, like just cancel out cosec, whatever, or maybe, perhaps factor out. And that was actually way back up here. If you feel the need to cancel trig functions or divide both sides by the same trig function, stop, factor, stop, collaborate and listen, factor and set equal to 0. Okay, do not cancel, because what happens there, if you cancel out a trig function, that's like canceling out a whole possible solution. All right, and we don't know if the solution is going to work, but we should at least find out what it could be. So if I take out a cosecant of theta, I'm left with cosecant of theta minus 2 equals 0, right? So I factor out a GCF. And the reason why I factored that is I don't want to remove the cosecant because then I remove a possible solution. All right, so cosecant of theta is equal to 0. And then for the other one to be cosecant of theta minus 2 equals 0, so it's going to equal 2. And I can deal with each one of these here. So cosecant is the reciprocal of sine, right? So think of this as 0 over 1, some number. And then this would be sine of theta is equal to 1 over 0. That is undefined. So this case, it does not work. Had this been like a cosine or a sine, then it would have worked. You would have gotten a solution. But because this was the reciprocal, it ended up being undefined, right? So in this case, if you cancel it out, it really wouldn't have mattered, but it would have been incorrect math, okay? Because this solution won't work here for this one. Sometimes it does, though. So for this one, again, we're going to use sine of theta and make this into a 1/2. Now, let's solve this bad boy. I'm going to position that. It's going to be in the first quadrant, 1, 2, that's a root 3. I know that this is and we're still asked for radians, I believe. It's been a while for this one. Yep, it is radians still. Cool, awesome. That was the last set of directions. So this would be pi over 6 as one of them. And then where else is sine positive? Well, that would be over here in the second quadrant. And that would end up being all the way, it would be 5 pi over 6. So pi over 6 and 5 pi over 6 for my two solutions. Love it. So the one was undefined. This one works. Awesome, fantastic, wonderful. So don't cancel trig functions out, right? We're going to factor using U substitution. Any GCF you take out, set that bad boy equal to 0 just like you would in normal factoring and solving just like we've done in Algebra 1 and all the other classes, before this one. So awesome sauce. I'll let you guys go on this one. Have a great day. America, freedom, rock and roll, Costco. Riverdog Jenny on the gram. Deuces.